Alright, so we're going to be going over the review for the ionic nomenclature and bonding unit that we're going to be finishing up. We're going to have a test in the next class period or so, depending upon when you're watching this. And so I wanted to take a look at, this is the material you'll need to know. Make sure you understand the differences in the periodic table. This should all be review. We need to understand naming. If it's binary, we're simply going to name the metal first and then change the non-metal ending to IDE. When we're naming binary ionic, if the metal is a transition metal, and remember for me there's three questions, and I say, is it in group 1, is it in group 2, or is it in the staircase? And if the answer to all of those is no, then you need a Roman numeral. So when I'm looking at the polyatomic ions, we're going to list the metal first, or in the case of ammonia, we'll list that first, and we're simply going to write the name of the polyatomic. When we're naming our binary acids, we're going to use the prefix hydro. Okay? Otherwise, remember, we're going to have to change ates to ix and ites to ous. You can remember that I ate something and now I feel icky, and Sprite is delicious, to help you remember which one goes where. Cations, this should say usually metals, ions with positive charges because they lose electrons. Anions are usually nonmetals or polyatomics, and they have a negative charge. They have extra electrons. The oxidation number, or the oxidation state, is the current charge of the ion. Valence electrons, of course, are the electrons in the outermost energy level. You're going to remember to crisscross, because the idea here, and that's when we were doing this, we're taking our numbers and we're going from the top down. The idea here is that we're trying to solve and get the final compound to have a final charge of 0, and that's the plan there. Be sure and check your notes for metallic bonding and alloys. There's going to be a few questions about metallic bonding just so we can get that covered. Talk about the three bond types, the difference between ionic, covalent, and metallic, and know that ionic compounds transfer electrons, that covalent compounds share electrons, and that metallic compounds have a sea of electrons surrounding the core. Understand how to do electron dot structures, be able to look at the oxidation states, know your polyatomics. Know your polyatomics. There's going to be a section on the exam that is not multiple choice, that you're going to have to do free response. So let's start with our Lewis dot structers. We're going to start with magnesium. And I tend to want to write a little bit bigger so you guys can see what's going on, so that's what this separate piece of paper is for. Let's take a look at magnesium. So I've got magnesium. I'm going to write the element symbol in the middle there. And I want to take a look and show you where magnesium is on the periodic table, or remind you, I'm sure you know. So magnesium right here is in column 2. It's in group 2. We call these the alkaline earth metals. Magnesium's in group 2. It's going to have two valence electrons. And so I'm going to draw 1 and 2. And remember, with our Lewis dot structures, X being any element, this is 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's how we're going to draw those. That's going to help us out. Let's now look at fluorine. Fluorine there, back here, and you'll see fluorine is right here. It's in group 17. It's a halogen. Well, those in group 17 are going to have 7 valence electrons. So we're going to draw these 1, 2, 3, 4, 5, 6, 7. Let's take a look at oxygen. Oxygen, if we look at our periodic table, oxygen is going to have 16. It's in group 16. It's going to have 6 valence electrons. So oxygen is going to have 1, 2, 3, 4, 5, 6. 6 valence electrons. And finally, let's take a look at argon. The symbol for argon is Ar. Argon is a noble gas. So let's take a look at argon. So there's argon. It's in group 18. It has 8 valence electrons. So it has a full shell. And if you remember, that's why our noble gases are not going to be reactive, is that they already have a full shell. And so let's go ahead and draw the Lewis dot structure for argon. 1, 2, 3, 4, 5, 6, 7, 8. And you can see this has got a full shell. Well, this is actually the configuration that most atoms are trying to achieve. Remember, there are some exceptions in hydrogen and helium. They both want 2. But most, this is going to be the octet rule. Most of our elements are going to be trying to get to 8 or a full shell.
Good morning, Oak Ridge.
So what's going to happen here is that the metals, like magnesium, will lose these electrons. And then they'll have a complete outer shell like the noble gas that happens before them. So in the case of magnesium, the metal gas that happens before them is going to be neon. And so it'll still have a full outer shell, but it will have lost that outer ring. Fluorine and oxygen will tend to gain electrons. So in fluorine's case, it's going to gain 1 electron, and then it'll have 8. In oxygen's case, it will gain 1 and 2 electrons, and it will have 8 as well. Argon already has 8, so it doesn't need to react. What does that mean in terms of naming? Well, let's take a look here. Barium sulfate. So if we look at our periodic table, barium is right here. Oh, there we go, right there. There's barium. Barium is in group 2. Barium has 2 electrons in its 2 valence electrons. And if it loses those 2 negative electrons, it's going to end up with a positive charge. And so barium would have a +2 charge. Now let's take a look here. Sulfate, that ATE, is a signal for me that's a polyatomic ion. Remember, those are the things we need to go ahead and have memorized. And so a polyatomic ion, sulfate, is SO4, and it's -2. If you remember our lecture about the outies and the innies, that will help you remember it. But simply getting these memorized will really be a big step for you in chemistry. Now what I'm going to do is I'm going to crisscross. So this 2, what I mean by crisscross is this 2 is going to go down here. This 2 is going to go down here. And it might look like I'm going to end up with Ba2 SO42. But remember, we always want the lowest whole number ratio. And so we need to simplify, and our answer is going to be BaSO4. And you can also add parentheses if you need to help you remember that sulfate stays together. It's a polyatomic ion. So that's going to be our solution there. Let's take a look now at lithium sulfide. So going back to our periodic table, I can find lithium right here. Lithium's right here in group 1. Lithium has 1 valence electron, and if it loses that 1 negative charge, it's going to end up having a positive 1 charge. So I'm going to say Li plus 1. Sulfide, which you can see in your example here, but let's go ahead and take a look at it from the periodic table. Here's sulfur right here. There we go. There's sulfur right there. It's in group 16. It has 6 valence electrons. It is a nonmetal, and nonmetals will gain electrons, and so it's going to gain 2 electrons in order to look like argon. So it wants to look like argon, so it's going to gain 2 electrons. And you can tell, you can go 1, 2. And so sulfide is S minus 2. I'm going to take these numbers, I'm going to crisscross them. And so my final answer is Li2S. Sodium hydroxide. Well, looking at our periodic table, we see that sodium is in group 1. So I'm going to Na plus 1. Hydroxide is one of our polyatomic ions that we need to have memorized, and that's OH minus 1. I'm going to again crisscross these, and I end up with NaOH. And you don't need parentheses if there's only one. I'm only suggesting it for you guys right now that it might be helpful to have parentheses to remind you again that it's a polyatomic ion and it stays together. If you have more than one, you must use parentheses. So just keep that in mind. Ammonium chlorate. Well, if you look for ammonium on the periodic table, you will not find it. There is nowhere on the periodic table will you find ammonium. And the reason is ammonium is our polyatomic ion that has a positive charge. And again, that's something we need to have memorized. So NH4, with a plus charge. And chlorate, that 8 is a signal to you that it's a polyatomic ion. It also is something we need to have memorized. And so chlorate, let's go back and look at our periodic table. Chlorine is an Audi. If you remember the antes and the Audis, that means the 8 form, the ATE form, is going to have 3 oxygens, and it's a halogen. It's going to have a -1 charge. So chlorate is ClO3 minus 1. I'm going to crisscross these, and each one of those is 1. So it's NH4 ClO3, ammonium chlorate. Alright, so we're going to continue here. We've got zinc sulfate. So if you'll remember, zinc is one of our elements here, and the silver, so I can go from silver up here to aluminum. Zinc, silver is always +1, zinc and cadmium always +2, aluminum, gallium, and indium always +3. So we call that, or at least I call that, the silver aluminum staircase, and that helps you remember that these guys don't need Roman numerals because they always have the charge. They always have a charge. In fact, that's why we need Roman numerals. So we can go ahead and put zinc, and it's going to be +2. And again, sulfate, we did sulfate up here, so that's one of our polyatomic ions. Again, 8 lets me know it's polyatomic. SO4 minus 2, and after I crisscross these, I would end up with ZN2SO42, and I'm going to simplify that because, and then again, we need our lowest whole number ratio, and so that's going to be ZnSO4. All right. Iron 3 phosphate. So iron is a transition metal in the middle of the periodic table, number 26, and the symbol for iron is Fe. And this Roman numeral right here, this Roman numeral 3, tells me that I'm talking about the iron, the cation iron that has a +3 charge. And phosphate, again, the AT, that's a polyatomic ion. That's PO4 phosphate, and PO4 phosphate has a -3 charge. Again, we're going to crisscross. Now that I have the charges written, we're going to crisscross. So this +3 here goes over here, and this goes over here, and I would end up with Fe3PO43. As a reminder, we need the lowest whole number ratio, and so we simplify that to FePO4. Okay. Nickel 2 hydroxide. Again, nickel, and I'm going to have it +2 because the Roman numeral here tells me this should be +2. Hydroxide, we did hydroxide up here. It's the same thing. It's OH -1. I'm going to crisscross that, and I end up with NiOH2. This case, it's very important you have the parentheses, because otherwise you would say this is nickel with 1 oxygen and 2 hydrogen. But what I want to say is I've got nickel with 2 hydroxides. So for every 1 nickel in our crystal structure, I have 2 hydroxides. Let's look at copper 2 nitrate. Copper, Cu, charge is +2. Nitrate, again, is something we need to have memorized. That's NO3 -1. I'm going to crisscross those, and I end up with Cu NO3 2. Alright, very good. I've got copper carbonate. So this is Cu2 and CO3 is carbonate. So let's break this apart. Carbonate, and so I'm going to write this copper, Cu, and carbonate, CO3. Now carbonate has a charge of -2, and that's something we memorized when we memorized our polyatomic ions. What I don't know is what the charge of copper is. You notice I didn't put a charge here. Well, I'm going to look at this, and I'm going to make a little T-chart. Go back to our blank piece of paper here. Sometimes we need a little more space. Cu2, CO3. All right. I'm going to break up. This is my anion. This is my cation. Okay. And I don't know the charge of copper. I do know that copper needs a Roman numeral. And so I'm going to have to figure out what that Roman numeral is when I'm naming it. So I'm going to put copper here, leave a little space for Roman numeral, and carbonate. Now carbonate's charge is -2, and I have 1 of those. So 1 times -2 is -2. This is my total anion charge. That means my total cation charge, and I notice up here there's nothing, so this has got to equal 0, +2 plus 2 minus 2 equals 0. This is what I'm trying to solve. What I need to know is what's this charge. So I'm going to say +2 divided by, I have two coppers here. Okay, I have 2 coppers here. So divided by 2 equals +1. That means that this copper is copper 1 carbonate. This copper has a plus, each of these 2 coppers each has a +1 charge. So that's how you can tell what the Roman numeral is going to be for a metal, for one of those transition metals. Let's look at this next one. Magnesium. Now magnesium, if we remember, magnesium is in group 2, right here. Magnesium is in group 2. Right there, magnesium is in group 2. It has 2 valence electrons. It's going to lose those 2 electrons and have a +2 charge. So this magnesium is +2. P is phosphorus. It's -3. And I don't need a Roman numeral because magnesium is always going to be +2. Add that there. So this is just magnesium. And this is P by itself, so be very careful. This is phosphide. Phosphide. Let's look at this one. This is aluminum. And NO3 is a polyatomic ion, that's nitrate. And I look at aluminum and I find that I notice that aluminum is over here, right here, and it's in the silver aluminum staircase. Aluminum always has a +3 charge when it's in a compound, and so I can just, it's Al +3, and nitrate is NO3 -1, -1. And I don't need a Roman numeral, so I can just write aluminum nitrate. Finally, let's take a look at this one. This is Na, which is sodium. And sodium is in group 1. Group 1 does not need a Roman numeral, so I can go ahead and just write the next thing. This is Na. Sodium always has a +1 charge. PO4 is phosphate. Just to fill this out, that's -3, and that's phosphate. Okay? Let's move on to a little bit of vocabulary. It's going to be really important that you remember this. In an ionic compound, in ionic compounds, ions are formed when bonding a metal and a nonmetal. Cations are positive ions formed by losing electrons. Anions are negative ions formed by gaining electrons. During this bond, electrons are transferred. So let's go through this again. In ionic compounds, ions are formed when bonding a metal and nonmetal. Cations are positive ions formed by losing electrons. Anions are negative ions formed by gaining electrons. During this bond, electrons are transferred. All right. We have more naming and formula writing, just like we did on the previous page. So continuing on, we're going to do this. Magnesium chloride. My cations are going to come first, so there's magnesium chloride, so magnesium is Mg. I look at my periodic table and I know that it has 2 valence electrons. It's going to lose those 2 electrons. It's going to have a +2 charge. Chloride is my anion. Calcium, again, is in group 2. It's going to have a +2 charge. Fluorine is my halogen, -1. Calcium has a +2 charge. Oxide is -2. If you'll look at the periodic table for oxygen, what you'll notice is that oxygen is in group 16. Group 16. It has 6 valence electrons. It wants 2 more. When it gains those 2 more, it's going to have a -2 charge. So that's what happens there. K3PO4. Potassium. Potassium has a, well, what this has is a wrong formula. Let's go ahead and cross this out. We're going to go ahead and make it correct. This is K3PO4. Okay, so we'll go ahead and do that. That's +1. PO4 is -3. MgF2, magnesium, +2. Fluorine is -1. Barium Barium is also plus 2. Iodine is minus 1. Sodium is plus 1. Sulfur is minus 2. Magnesium is plus 2. Chlorate, ClO3, polyatomic ion, is minus 1. And this should also be corrected. There we go. Sodium, Na, is plus 1. Fluorine is minus 1. Okay? We good so far? Let's go ahead and name this. Calcium. You notice all these cases, none of these guys need Roman numerals. They're not transition metals, and I knew the charge. I didn't have to calculate the charge looking at the anions. So I can just write, this is calcium. Calcium fluoride. This is calcium oxide. This is potassium phosphate. This is magnesium and then fluoride. This is barium iodide. This is sodium sulfide. This is magnesium chlorate. Okay, and notice the 8 here and the 8 here. Looking at those are polyatomics. And this is sodium fluoride. Okay. Now look at this one. This is an interesting one. I've got, this is water, okay, and this is not an ionic compound. And so I want to leave it alone, but I could write it as an acid. So we're going to break this apart. It's not really an ionic compound in a formal sense. However, it is important to be able to look at this and break it apart. And notice it starts with H and it doesn't have a charge, so it can be an acid. And we'll talk about this in the spring, how water is both an acid and a base. But just so we can break this apart right now, I can break this apart as hydrogen and hydroxide. Okay? I'm not going to name this right now because I don't want to get into confusing y'all, and this won't be on a test, but I really wanted to show you that this can be a cation and an anion, how these can break apart. And this is actually how water can be an acid and a base at the same time. Let's continue on to cesium oxide. So let's look at our periodic table. We'll find cesium for you. It's right here. It's in group 1. That means it's going to have a +1 charge. So I'm going to have CS +1. And oxide is O -2. Oxide's going to be -2. I'm going to crisscross these, and that's going to give me CS2O, cesium oxide. Aluminum phosphate. Remember that 8 sets into mind that this is going to be a polyatomic ion that I've memorized. And I have PO4, and that's going to be a -3 charge. And aluminum, I'm going to look at aluminum, that's Al. And again, I'll look over here on my periodic table, and there's aluminum right there. It's in group 13. Remember, aluminum is part of our silver aluminum staircase with a +3 charge. So aluminum is +3. I notice that this is a -3 and a +3, and when I crisscross those and reduce them to the lowest whole number ratio, I get AlPO4. Then I get beryllium oxide. Beryllium, again, let's go back to the periodic table. Beryllium is right here. Beryllium is going to be +2. It's going to lose 2 electrons. It's going to have a +2 charge. It's in group 2, +2 charge. So that's Be +2, oxide, oxide -2. I'm going to crisscross this, okay, so that they crisscross. That's going to get Be2O2, and of course we want the lowest whole number ratio, so that's going to simplify to BeO. Aluminum carbonate, so Al +3 as we saw earlier, carbonate, CO3, okay, -2. And if I go back to the periodic table, here's carbon, and so carbonate, you see carbonate, carbon's an outie, so the 8 form is going to have 3 oxygens, and you can remember that carbonate is -2. I'm going to crisscross these, so this 3 is going to come down here, this 2 is going to come down here, and remember the goal of this is to get the total charge to 0. So this is Al2, CO3, 3. Lead 4 oxide, so lead is Pb. This tells me that lead has a +4 charge. Oxide is -2. So if I were to crisscross that, that would give me Pb2O4, because I'm bringing the 4 down here and the 2 down here. But again, I need the lowest whole number ratio, so I can reduce that to PbO2, and that's what I'll put here, PbO2. Iron 3 oxide. Iron is Fe. This is iron 3 I'm talking about. So iron 3 is +3. Remember, that's what the Roman numeral tells you is the charge. Oxygen is -2. I'm going to crisscross those. Fe2O3. That's iron 3 oxide. We commonly call that rust. Lithium is Li. Li, looking at the periodic table, is in group 1. It has 1 valence electron. It will lose that 1 valence electron and become positively charged, and it will have a +1 charge. Hydroxide is OH minus, and so -1, that's going to crisscross, LiOH. Calcium phosphide, Ca, calcium is in group 2, +2. Phosphide, phosphorus, is in group 15. It needs 3 additional electrons to look like the noble gas, so it's going to have a -3 charge. We're going to crisscross these, and I end up with Ca3P2, calcium phosphide. Let's take a look at element number 1, element number 2, and element number 3. Element number 1. What is the name of these elements? Remember the protons. I want to like super duper emphasize this. Protons define the element. So I'm looking at the periodic table. We're going to look at number 3, 12, and 17. So looking at the periodic table, element number 3. This is element number 3. I'm looking right here. Element number 3 is lithium. Okay? The next element I'm looking for is 12. Who has 12 protons? Well, let's keep going. Over here, 12 protons. 12 protons is magnesium. remember the protons. The protons, the atomic number, that's what defines the element. Okay. The next element we're looking for has 17 protons. That is chlorine. All right. So when the number of protons and the number of electrons are equal to each other, they have a charge of 0. That means they're neutral and they're not an ion. So let's look at element number 1 has plus 3 protons, has minus 3 electrons. Plus 3 minus 3 is 0. So I'm just going to write a 0 here. Let's look at element number 2. Element number 2 has plus 12 protons, has minus 10 electrons. Plus 12 minus 10 is plus 2. This has a plus 2 charge. Number 3 also is 17 minus 17, which is 0. So element number 2, magnesium, or number 2, is an ion, and its charge is plus 2. Plus 2.